And good morning, fourth grade students. Welcome to Eureka Math. What does Eureka mean in Latin? It means I have found it. And what have we found? We have found the best gosh darn way to learn math. And that, my friends, is more valuable than gold itself. Let's dig right in with our fluency practice. And we're going to write the decimal of a fraction. You can write right here. You can follow along right with Mr. Leggett. And let's start off with this fraction. Now, I'd like you to say this fraction in your head. You're probably saying 1/10. If you're saying that, you're absolutely correct. Let's complete this number sentence, though. 1/10 equals something, point something. Who could tell me, or think to yourself, what would that be? Well, 1/10 I know is less than 1, so a 0 has to go there. And we have our decimal point, so voila, there we have it. We have 1/10. And I'm just checking my screen here, folks. Looking good. Let's give it another try with another fraction, 2 decimal. Scroll up a little bit. And let's write 2/10 equals, what would that equal? Well, I know 2/10 is less than 1, right? The numerator is smaller than the denominator, so a 0 must go there. But how many tenths is it? Well, it is 2/10, so we have 0.2. Let's continue on, and we'll try 7/10. That would equal, what would that equal? Well, so once again, the numerator is smaller than the denominator, so it must be less than 1. How many tenths are there? There are 7/10. And we'll keep going on with 9/10. What will this equal? Well, take a look, 9/10, still less than 1, so 0 must go there. And there's our 9/10. Let's try another one. This time around, we're going to convert a decimal to a fraction. So we're going to start off with 0.3 or 3/10. What would that look like as a fraction? Well, if you said 3/10, you would be absolutely correct. Let's try a few more. We'll do 0.4, our 4/10. And how would that look like as a fraction? Go ahead and fill that in. If you put a 4 on top and a 10 on the bottom, you are absolutely correct. 4 is your numerator, 10 is your denominator. Go on with 0.8 or 8/10. I said tenths, so automatically our denominator is going to be 10, and our numerator would be 8 to show 8/10. Let's keep going and do one more. We'll have 0.9. What will that equal? Go ahead and think about that one. Fill it in on your own. I'm sure you can by now. And that would be 9/10, of course. Let's head over here to the next column. And we're going to look at this fraction, 10/10. What do we think 10/10 would equal? Well, the numerator is the same as the denominator, and whenever that happens, it equals the number 1. And there we have it, our fluency practice. Let's move on to the application problem, and it's a doozy. So don't need to get out your highlighter. We won't work with a highlighter, just work with your pencil. I'll work with a green pen. And let's read what's going on. Well, yesterday, Ben's bamboo plant grew 0.5 or 5/10 centimeters. So that's something we know, so we underline that. We also know now today it grew 8/10 centimeters, so that's something else we know. And what we need to find out, and I do the squiggly line for this, is how many centimeters did Ben's bamboo plant grow in 2 days? So let's take a look at all of our numbers and circle them. We have 5/10 of a centimeter, 8/10 of a centimeter. Notice this is a decimal and that's a fraction. And 2 days. So we got a lot of figuring out to do. Let's get right on that. So we'll scroll up a little bit. And we'll start off with a tape diagram. And this tape diagram is going to represent Ben's bamboo plant. So rather than writing Ben's bamboo plant, I'm going to draw the parentheses, a bracket, and just put a big B there for Ben's bamboo. Now, how many days did Ben's bamboo grow? Well, it was a total of 2 days. So let's split this in half. Because remember, we're trying to find out how many centimeters did Ben's bamboo plant grow in 2 days. There's day 1 and day 2. Well, day 1, it grew 5/10 of a centimeter. Now, because one of the days is in centimeters, decimal, and one is in fraction, we need to figure out which one we're going to deal with. Let's just go ahead and deal with fractions. So I'm going to go 0.5, and it's just like our fluency practice. That's going to equal what? How many tenths? Well, we should know that it equals 5/10, right? So for day 1, we could say that Ben's bamboo plant grew 5/10 centimeter. Day 2, we already have that in fraction form. It grew 8/10. But what we need to find out is how much it grew during those 2 days. So let's go ahead and do a math sentence so we can, I forgot something over here. Centimeters. So let's go ahead and add these together to show how much they grew in 2 days. So we're going to start off with 5/10 plus 8/10. How many tenths will that equal? Remember, we do not add the denominators. They stay the same. So 10 remains the same. We add the numerators. What's 5 plus 8? Well, think about that. I can go 1, 2, 3, 4, 5, and then add 8 to it. 1, 2, 3, 4, 5, 6, 7, 8. So I have 5, 10, 11, 12, 13 tenths. But what would 13 tenths equal in a mixed number? Because I know that having a numerator that's larger than the denominator is an improper fraction. So we got to turn that into a mixed number. Remember back in our fluency practice where we said 10 tenths equals 1? So couldn't I do this? Subtract that 1, right? And I'd be left with 3 tenths. So it looks like I would have 1 and 3 tenths would be my answer. So we could say Ben's bamboo plant grew 13 tenths are 1 and 3/10 centimeters in 2 days. Way to go, Ben. And your fabulous bamboo plant. For the next part of our lesson, we're going to need a ruler. So take your ruler out. If you don't have one, wave your hands frantically, and Mr. Leggett will get you one. We'll stop teaching his lesson to the 5th graders. Get you a ruler. So today, in our concept development, we're going to be learning to use metric measurement and area models to represent tenths as fractions greater than 1 and decimal numbers, okay? A lot going on there. So, let's start off. We're going to turn our page. And your paper should look, you know what? Your paper will look like this. We're going to be dealing with some models here. Make sure they're in the right place. So right there is our, turn it on the horizontal. So the first thing we're going to do is take our ruler, and we're not going to use the inches. Remember, we're using metric measurement. So let's turn it to the side that says centimeters. So we're going to draw a line the length of 2 centimeters. So let's go ahead and do that. I'll start at the 0, and I'm going to stop at the 2. A little bit further. So there's my 2 centimeters. Alright, so now, we're going to label this 2 centimeters. So I'm going to put a 2. Please follow along with me. 2 cm. 2 centimeters. That's how long 2 centimeters is, right there. Check my camera work. Make sure you boys and girls can see this nice and neat. Excuse me. Okay, so, well, let me zoom out just a tad so I have a little more room to work with. Okay, that's looking good. So that's 2 centimeters long. So now let's add on not 6 centimeters, but we're just going to add on 0.6 centimeters. So right there. So I have my 0 there, and I'm going to add on 6 more. And if you need to pause to catch up, that's thoroughly understandable. So I have my 2 centimeter mark right here, and I'm adding on another 6 centimeters, or 6/10 of a centimeter. So I have 6/10 of a centimeter here. Well, what would that equal? We would have 2 centimeters and the 6/10. So it would just be 2 6/10 of a centimeter. We could do this with decimals too. I could do 2 centimeters plus 0.6 6/10 of a centimeter would equal 2.6 centimeters. Got that? Now let's just do another one while we got your attention here. And we'll just scroll up a little bit. And I'm going to draw 3 centimeters. See, on the centimeters, they're broken up into millimeters, 10 millimeters. So I'm going to start at 0 and go to 3. A little further. This time around, I'm going to make a little mark here to show that this is 3 centimeters. Okay? So go ahead and do that with your ruler. Mark up 3 centimeters. And we're going to add on to this. So let's add on 5/10 of a centimeter. And we have that little mark right there to show us that's 5, or halfway. So I'm going to go right up here. And do 5/10 of a centimeter. So I have 3 centimeters, and then I have 5/10 of a centimeter. And what would that equal? Well, I know 3 plus 5/10 is simply 3 5/10 of a centimeter. But also we could do this. I could do 3 centimeters plus 0.5, or 5/10 of a centimeter, would equal 3.5, or 3 5/10 of a centimeter. Excuse me. So now, let's take a look back at this problem here. I'm going to scroll up right over here. And we're going to show how many total tenths are in that 2.6 centimeters, okay? So let's take a quick look at this. I'm going to zoom out just a tad. Oh, not zoom in, zoom out, Mr. Leggett. All right. So this represents 1 centimeter right here, okay? That's 1, 1, 1, and so on. So I'm going to go ahead and label these. Let's bracket them out. And we'll lay them 1 centimeter, 1 centimeter, 1 centimeter. So these are tenths of a centimeter. So let's do our first one. We have a total of 2 centimeters, right? So let's go ahead and go. I'm going to color them all in to show that this is 1 centimeter. So there's 1 centimeter. Let's do 2 centimeters now. So I have a total of 2 centimeters right here. Now how am I going to show the 6/10 of a centimeter? Remember our problem down below here? Where it was right there. we have the 2 centimeters here, but we're going to add the 6/10. So I would just color in 6 of these. 1, 2, 3, 4, 5, and 6. So we have 2 total and 6/10. Let's try something else now, okay? Let's just give this a shot. I know you'll. Let's make a model for the number 3 and 2/10. Okay, we're doing 3 and 2/10. Okay, so I'm going to make sure we're in here. Good. So remember, each one of these represents how much? Each one of these models represents 1, right? So I'm going to go ahead and do this up here. 1, 1, 1, and 1. So I have 3 holes, 3 whole ones, you know, whole ones, 10/10. So I can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's 1. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. So I'm at 3. There's my whole 3. My 3 centimeters, 3 inches, 3 whatever. But now I have to add the 2/10. Okay, I have my 3 holes, and now I'm adding my 2/10. So let's go ahead and do that. 1/10 and 2/10. So now when we look at this, we can say 3 plus 2/10 are 0.2 equals what? 3.2, or 3 and 2/10. We're going to do another one. This one's going to be a little trickier before we tackle our problem set. And what we're going to put down here is 48/10, okay? Improper fraction. Well, I never. So we have 48/10. All right? So it's very improper. And whenever I think of improper, I think of the math mutt. Uh-oh. I think I hear the math mutt coming right now. Oh my goodness, this is an improper fraction. I do not know how to deal with this, Mr. Leggett. It is very, very improper. Well, Math Mutt, if you follow along, you'll be able to see what kind of, if you follow along, you'll be able to see how to turn that improper fraction into a mixed number by using these these area models. Area models! Maybe that will make things somewhat clearer for me. Otherwise, this is so confused. How can they take that and make it into a whole number and a fraction or a decimal? I'm just dying to find out. Well, you don't need to die to find out, Math Mutt. You can just relax and watch what happens. And maybe you can go home and watch the video again, okay? Oh, thank you, Mr. Leggett. I love your math lessons. Eureka, eureka, eureka. Well, he's very excited, no doubt. So we have 48/10. Well, let's start making some tenths. Here's our 1 whole, and that's 10/10. I'm going kind of fast. There's 20/10, 30/10, and 40/10. So here total we have 10/10. 1, 2, 3, and 4. Remember, each one of these groups of tenths, of 10/10, symbolizes what? 1. So there's 1, 2, 3, and 4. So 4 ones must equal 10, 20, 30, 40 tenths. Okay? So how many are left to do? Well, what's 48 minus 40? It would just be another 8, right? So we would go 1/8, or 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, and 8/10. So this equals 40 tenths plus 8 tenths, right? There's our 40 tenths, There's our 8/10. But let's make this a decimal. How in the world am I going to do this? Well, these are whole numbers, 1, 2, 3, and 4. There's my 4 and there's my decimal. How many tenths do I have down here? 1, 2, 3, 4, 5, 6, 7, 8. So we have 4 and 8/10. Got it? Good. Now, ladies and gentlemen, boys and girls, damas y caballeros, we're going to get to our problem set. Mr. Lang can find his problemo setto. I hope I can, because it's a good one. It's a good one. Oh, excuse me. Oh, they're right over here. So, what we're going to do is we're going to rip out page... Excuse me. Boy, it's cold as got, Mr. Lang. Rip out page number. And this will help you, no doubt, on your homework. Rip out pages 3 and page 4. 3 and 4. So, let's just go ahead and do a few together. Then I want you to work on your own, okay? So, we're going to start out with, zooming in is what we're going to start out with. Our instructions are, for each length given below, draw a line segment to match. Express each measurement as an equivalent mixed number. All right, so what we're going to do is this. We're going to take our ruler, and we have 2.6 centimeters. We're going to measure 2 centimeters. All right, there's our 2. But we're not done yet because we need to do the 6th. Because it's 2.6, so I'm going to add on another 6. So we have 2 centimeters and 6/10 of a centimeter. See how this is becoming a fraction now? So we could say 2.6 equals 2 and 6/10. We're going to do one more together, and then you're going to be on your own. So this one is 3.4, so I'm going to make the 3. There's my 3 centimeters. And I'm going to add on 4/10, not 4 centimeters, but 4/10. And we don't have to be so exact here. So there's 4/10. Remember, there's 4/10 right there. So we would say, excuse me, I forgot my centimeters up there. Got to keep those measurements intact. So I'd say 3.4 centimeters equals 3 4/10 centimeters. And please do the lines, and please make the models like that. Let's go to number 2. Don't skip those for now. We'll come back. It says, write the following as equivalent decimals. Then model and rename the numbers as shown below. So 2, we have to remember we have to write them as equivalent decimals. So 2 ones and 6/10. Well, there's 2 ones, 0.6. Now to write them as a decimal, we would go like, with our area model, we're going to go draw 2 holes. I'm not going to be so exact on the holes. And then 6/10. These I got to be exact on. 1, 2, 3, 4, 5, and 6. So that shows me that 2 and 6/10 equals 2 plus 6/10 equals 2 plus 6/10 equals 2 and 6/10. We're going to go back here, and it's more of the same. I think you can get this. Remember, each one of these is 1 whole or 10/10. Okay? So when you get down to this one, 37/10, all you have to do is count them out. Right? Okay? And this one, they're going to ask you how much more is needed to go to 5. So you'll just have to think about, there's total is 5. How many tenths do you need to get to 5? All right? So that is what you're doing, and then we'll debrief and be ready for our exit ticket. Thank you very much. Do you think you understand now, Matt Mutt? Are you the math mutt? I'm the math mutt, and I totally understand. Thanks to your excellent directions, Mr. Leggett. How?